Good evening, everyone. We're just about to get started here. So before I introduce our speaker tonight, I'll just give you guys a few informations. So the Yukon Science Institute is a non-for-profit organization that seeks to promote public awareness in science activities in the Yukon and to facilitate research and development. As part of our mandate, YSI coordinate this lecture series. YSI is funded by the Yukon Department of Tourism and Culture Heritage Branch, Environment Yukon, and supported by the Beringia Interpretive Center. Just a reminder too that memberships for 2016-17 will be available at the membership table after the lecture. This year, for the first time in over 15 years, we've raised our membership fees in order to keep bringing new and innovative perspective on science to Yukoners. Please join. We'd really appreciate the support, and with it, you receive emails about upcoming lectures. Also, just a reminder that tonight's lecture will be video recorded. Tonight, Mike Flannigan will be delivering the lecture, Hot and Smoky, Is This Our Future? Mike Flannigan is a professor with the Department of Renewable Resources at the University of Alberta and the Director of Western Partnership for Wildland Fire Science, a three-way partnership with Alberta Agriculture and Forestry, Natural Resources Canada, and the University of Alberta. He receives his BSc in Physics from the University of Manitoba, his MSc in Atmospheric Science from Colorado State University, and his PhD in Plant Science from Cambridge University. Dr. Flannigan's primary research interests include fire and weather-climate interactions, including the potential impact of climatic change, lightning-ignited forest fires, and landscape fire modeling. He has been studying fire for over 35 years and has published over 200 papers. Dr. Flannigan was the editor-in-chief of the International Journal of Wildland Fire from 2002 to 2008 and has taken on leadership roles with the U.S. National Assessment on Global Change, the Intergovernmental Panel on Climate Change, the IPCC, the International Geosphere Biosphere Program Fire Fast Track Initiative, and the Global Change Terrestrial Ecosystem Efforts on the Global Impact of Fire. Wow, that was a mouthful, all these acronyms. Dr. Flannigan? Whoa.
Yeah. Yeah, you want to turn it off, down. All right. Whoa. Okay. I'll try this one. If it gets really bad, I'll go back to the lectern. Okay. I don't know about this. It's a pleasure to be here, and it's kind of winter has arrived, and it's good to see so many of you out. But you are, and I think I can almost. Let's do this. All right.
Let's do that.
Okay. So apologies for all the modern technology that I'm not sure if it's working.
I'll do penance out the back while you all enjoy the lecture. Yep.
a pleasure to be here. It's a snowy night, and it's good to see so many people out. But you are Yukoners, so you're a tough lot. And I've been interested in fire from just about day one. My first birthday, I had a cake and a candle, and one candle, and I put my finger in that candle because I was just drawn to the flame. But I was so drawn that despite tears, I kept my finger in that flame, and my parents let me keep it there until they got the camera and took a picture of me crying with my finger in the fire, and I've been sticking my finger in fire ever since. So it comes naturally. I feel very fortunate. I get to do something I love, and so I get to share a little bit of that with you tonight. And I also was a weather forecaster for Environment Canada for a number of years, and at times we have trouble forecasting the weather for the next day. So it may be a bit presumptuous for me to suggest that I may be forecasting what's going to happen later this century, but we're going to look at possible scenarios or possible things that may happen, and there are some things that give us insight as to what the future may hold. That was a really nice introduction. For a while there, I kept on pinching myself that I'm not hearing my own obituary at my funeral or something with those kind words. I will talk a little bit more about the Western Partnership at the end. Wildland Fire Science is kind of a unique partnership. So today, this evening, we're going to talk about fire in Canada, a little bit about fire in Yukon, fire management, some options, climate change, and then fire and climate change. And you can see two pictures on the screen there, and I'll try and point these things out. And this guy seems to be working fine. So, except for, I guess I'm supposed to stand over here, so it can be taped. But the figure on the left shows fires in Quebec, and this band, that's smoke. So, Canada's famous for exporting hockey players, cold fronts, but now we can export smoke. And we smoked out New York City, Washington, D.C., and they were complaining about air quality. Well, this is what you get when you have fires and the wind blowing from the north to the south. On the right-hand side, this is a picture in November 2014, and this is a fire burning in peat. And I believe this one burned right through the winter. If Chris Johnson is here, maybe he can collaborate that or confirm that. But fires can burn through winter if they get underground. And we'll talk a little bit more about peat in a bit. So in Canada, we spend about $800 million on direct fire management costs. They have been rising. The graph, you can see that they're going up. It's not, it's bumpy because some years are bad fire years and some years are not quite so bad. Of course, health and safety of Canadians are the priority. There's lots of evacuations. I'll talk a little bit about Fort McMurray before we finish the talk. And impacts on economic activity. Smoke impacts, the more we find out about forest fire smoke, the more we find it's bad for your health, which isn't a big surprise. But with smoke, you can also have problems with transportation, air and road transportation because of poor visibility. And some northern communities have only access by air. So that can be a real problem if a fire is approaching a community and the visibility is so poor that the planes can't land to evacuate people out. Recent years we've heard about impacts on water supply. California, the Rim fire affected water supply for San Francisco. There's fires in Colorado. Fort Collins lost one of their water sources for 1 year due to a forest fire. And of course, there's property losses and timber losses due to fire. So, impacts. It's really like real estate. It really depends on the location. And for example, if the Fort McMurray fire had started about 100 kilometers to the east, we probably wouldn't be talking about it. But it started right beside a community and burned a good chunk of that community, so it made the news. And we don't have to go very far back in time. There's been fires in Russia, Greece, Australia in 2009, Black Saturday.
The United States has had almost bad fire years every year. Noticeably, 2015, Alaska had a very bad fire year, 5 million acres. Probably some of the smoke made it here on occasion. Saskatchewan, Alberta also had a very bad 2015. Slave Lake, a third of the town of Slave Lake burnt down in 2011. And of course, Fort McMurray in May this year, 2,400 structures lost. Research has shown globally that smoke-related fatalities are estimated at 330,000 people a year. This is mostly Southeast Asia, but it is significant. I think it's in the top 15 for mortality causes. So in Canada, our statistics numbers go back to about 1918, 1919, though they're kind of incomplete before 1970, arguably 1960 or 59, but the more recent period we have more confidence. Now, on average, 8,000 fires burned about 2 million hectares, maybe a bit more with the recent busy years. And that's about half the size of Nova Scotia. So there's a lot of landscape being burned every year in Canada. And it used to be about 1 million hectares in the early 70s. All of 70s is about 1.5 million hectares. So our area burned has doubled. And this is during a period where fire management has become more effective at fighting fire, and more the land base is covered by fire management. But we've seen a doubling in area burned, and colleagues and I believe this is due to human-caused climate change. Now, in the boreal, in Canada, most of the fires are crown fires. That means the crowns of the trees are engaged in flame. It's not independent of the surface. So the fire starts on the surface due to people or lightning, and I'll talk a little bit more about that, and grows and spreads on the surface. But if conditions are right, fuels are dry, and especially if there's shrubs and ladder fuels, we call them, that help carry the fire from the surface up into the crowns of the trees. They're high-intensity fires, stand renewing, stand replacing fires, and those are the common ones in the boreal. There's a lot of variability from year to year, and this I attribute largely to weather. Lightning fires, they start about 35% of the total number of fires in Canada. They represent about 85% of the area burned. And that's because they occur in remote areas, they occur in clusters. Another aspect of fire is that 3% of the fires are 200 hectares or larger. A hectare is about the size of a football field. But this represents 97% of all the area burned. So a relatively small number of fires are causing most of the impact, most of the area burned. These are large, intense fires. In the Yukon, the current average is about, the last 10 years is about 100,000 hectares per year. This current year, 2016, has been relatively quiet in the Yukon. I think you were around 20,000 hectares. Now, this is by decade showing fire on the landscape, and you can see that goes pretty well from coast to coast to coast, but this broad swath that cuts across is a break in eastern Ontario. This really fits the boreal forest quite well. And if we had Alaska on here, it would just continue right on into Alaska because the boreal forest continues right on into Alaska. So you can see there's lots of fire in Saskatchewan in particular. It's boreal shield country, very shallow organic layer. So it only takes 5-7 days for it to dry out and ready to burn, regardless of how much rain you've had before that. So it dries quickly and can burn quickly. So this is average annual burn in the Yukon, and you can it's kind of misleading, and I'll show you in the next slide why this is the case. And according to this, we've been going up until the most recent decade, but that last decade, the knots, 2004 was a very, for those of you that lived in the Yukon in 2004, will probably remember it was a very smoky, hot summer, and it was a very big fire year, as you can see on this graph. It does stick out like a sore thumb. So when you start doing averages, and this is where it gets tricky, because the smaller the spatial unit and the smaller the time, it's hard to say something with as variable as fire can be on the landscape. So you have to take things with a grain of salt and acknowledge that there's lots of caveats, and you know, it's forecasting is a hard thing to do well anyway. So 2004 was a memorable year, and close to 2 million hectares. I think it was about 1.8 million hectares, which is, as you can see, it has no other year comes even close in recent history. So let's talk a bit about fire ecology. So I mentioned that these are often high intensity crown fires. This means they renew the stand replacing, stand renewing fires. And for many of the species in the boreal, they have learned to survive and even thrive in a regime where you get stand replacing high intensity fires, you know, every 30 to 200 years, depending on where you are, longer if you're in Labrador or Eastern Ontario. But these fires allows sunlight to reach the forest floor. It removes the competition, it kills the competition, removes the organic layer, and for regeneration, a lot of trees prefer mineral soil. So standard, if you've taken succession in school, and they talk about climax succession, it really doesn't apply to the boreal because it's a disturbance-mediated regime. And usually it's fire, but sometimes it's insects. So WYSI, WYG is kind of from an old word perfect days. What you see is what you get. So if you see jack pine, lodgepole pine, spruce, they have serotinous or semi-serotinous cones. That means they're sealed with a waxy resin, and they need heat from a fire to open the cone so the seeds can be released. So they're self-perpetuating. Aspen suckers. And so you have a fire go through, and you get lots of aspen. I'm going to show some slides from Fort McMurray that show aspen stand right after the fire when I was there, and then just a few weeks ago. And it's amazing how well it's recovered. Some species can sprout from the root collar as well, some of the birches. So these trees have learned to survive with this type of fire. Now, this is, if you've seen me talk before, this is one slide that you'll see, because this is how I view fire. There are 3 ingredients you need for fire. And the first is the fuel, the stuff that burns, the needles, the leaves on the forest floor. How much you have, how dry it is, how it's structured. Remember I talked about, you know, having ladder fuels to carry to the crown. That's very important for crown fires to have that. Chemical composition plays a role. So all these aspects are important to determine fire behavior. So once you have the fuel, you need ignition, and lightning and people are the 2 common ones. And that bad fire year in Alaska last year, 99.5% of the area burned were due to lightning-caused fire starts. You go further south, people play a much bigger role. Now, I'm unabashedly biased. I think weather's the most important factor. You need all 3, but weather, hot, dry, windy, we call it. If you get hot, dry, windy weather for a number of days, then you're ready for fires to start and spread. Now, weather also plays a role in the other 2 factors. Fuel moisture is a function of the weather, and fuel moisture is critical in determining if a fire will start and spread. Also, lightning activity is a function of the weather. So weather is pervasive in all 3 ingredients, but you need all 3. So this is a map of evacuations and structural losses with respect to fire from 1980 to 2007. I believe this data set's being updated, but you can see that there are evacuations and structure losses from sea to sea to sea. So this isn't an Alberta problem. I was just talking to parliamentarians a few weeks ago, and I wanted to bring that home, that yes, Slave Lake happened, yes, Fort McMurray happened, but this is not an Alberta problem. This is a Canadian problem. So this is work done by one of my students, Lynn Johnston, and she's with Canadian Forest Service in Sault Ste. Marie. She just finished up her master's, successfully defended it. And there's something called the traditional wildland-urban interface. It's become vogue for people to live in the woods. It's gorgeous. You got gorgeous trees, you got wildlife, but there is a consideration with respect to fire, and we've called this the wildland-urban interface for years. Well, Lynn decided to look at the wildland-urban interface across Canada, but she also added the wildland industrial interface, which is really big in Alberta with all the oil and gas, and infrastructure interface, highways, roads, and you can see that in the Yukon and the north, it's really the transportation corridors where all the development is happening. And where you have people, you have fire, and that's just the nature of the beast. There was a recent op-ed in the LA Times saying that 60% of new home starts in the United States are within 2 kilometers of public land that is fire prone. And they likened it to building in a floodplain. That Americans aren't learning from all the disastrous fires they've been having. And I would argue that we're not really learning either. We don't have numbers like the LA Times article quoted, but I imagine we're rebuilding in exact same places where homes burnt down. And that's exactly what happened in Slave Lake and is happening as we speak in Fort McMurray. So, Smoky, fire management. Smoky has 2 messages. And the first message is that you can prevent forest fires. And that's a good message. But there's a more innocuous, it's a more nuanced message that fire is bad. And fire is not bad. It's part of our boreal system. In many respects, it's healthy for the forest to cleanse itself, to kill the bugs, the disease, and the older trees that are starting to decay, and reset the biological clock. It's a cycle of life. And that's the way the boreal forest operates. And to stop fire, our forest would change dramatically if we prevent all forest fires. And indeed, 60 years of trying to stop forest fires hasn't really worked that well because we have more fire than ever. And so we have to learn to live with fire, coexist with fire. Fire management agencies, our Canadian ones, are among the best in the world. We use something called the Canadian Forest Fire Danger Rating System, and this is the de facto global standard. This is used in many places around the world, and if you look at global fire danger, it's often the Canadian system that is used. The traditional approach has been total fire suppression. This is more for the southern tier, the provinces, than the territories. The territories, in many respects, are more advanced because they've allowed fires to play a more natural role, and that's appropriate. And now the South is finally catching up with the North, and places like Ontario and BC has monitor and manage. Ontario has appropriate response. And the best way I can liken it to is the emergency in a hospital. And patients come to the emergency room. Well, fires are like those patients. They come, and the fire managers say, do we want this fire? And if a fire starts close to a community, like the Fort McMurray fire, right away you say, that's an unwanted fire. Initial attack, you hit it hard, you hit it fast. If the fire is the size of this room or smaller, it's easy for experienced crew to put it out. If the fire is the size of a football field, and it's hot, dry, and windy, and there's dry fuels, we have a problem. So initial attack is very important. So making these decisions immediately once the fire is detected is critical. So, but if a fire starts 100 kilometers east of Fort McMurray, in the middle of essentially nowhere, they run fire growth models for the next 2 weeks and say, where will that fire spread? And if it doesn't spread towards a community or other value, they say, okay, let Mother Nature take her her role. Take its course. Let that fire continue to grow. We'll continue to monitor it and see if the weather forecast changes, if it changes direction, and we can tackle it then. So they're moving away from, fire is bad, you put every fire out all the time. So fire management is going to continue. So let's shift gears here and talk about climate and climate change. Climate, basic definition, it's the average weather and its variability over a region period of time. And it includes temperature, precipitation, wind, and often we use 30-year period for averaging the climate. What is climate change? It's just a shift. And climate change has been going on for years and years and years before people were around. And there's natural factors, which I'm not going to go into. There's solar variability. There's volcanoes can inject significant amounts of dust into the stratosphere, which will block solar radiation. And then there's geological change. The continents drift and move north or south, and that affects things. Human factors, greenhouse gases, aerosols, ozone, land use change. And we will talk a bit about greenhouse gases. And this is very simplistic, but the sun is about 5,800 degrees, and the wavelength's a function of the temperature of that body. So the wavelengths coming from the sun are what we call short waves. And the Earth is closer, average temperature is close to 298 degrees, about 15 Celsius. And so it emits long waves. Well, there's a number of gases that are transparent to short waves, but are opaque to long waves, or at least in different wavelengths of the long wave spectrum. And one of these is carbon dioxide, the one you hear a lot about, but there's lots of others. And indeed, the biggest greenhouse gas is water vapor. Now, water vapor is transparent, okay? You can't see it, you can feel it sometimes because it can be really muggy, but it's the most important one, and we have a natural greenhouse effect that's been going on before we started filling the atmosphere with carbon dioxide. And then carbon dioxide plays a role, and then there's all the others, okay, methane, nitrous oxide, et cetera, et cetera. So, and there's been some news recently about HFCs, and there was been an agreement to ban HFCs, which, if you recall, replaced CFCs, which were banned because it was damaging the ozone. I'm not sure what's going to replace HFCs, but this graph shows the lifetime of these various greenhouse gases and the greenhouse warming potential. So carbon dioxide's a 1, HFCs are 140 to almost 12,000 times more effective at trapping heat than carbon dioxide. So, and they can last a long time in the atmosphere. So it's probably a good thing to have an agreement on HFCs. But there are ones even worse or have more greenhouse warming potential than HFCs. The PFCs and the SFs, almost 24,000 times more effective than carbon dioxide. Now, they've been measuring carbon dioxide, Mauna Loa, a great place. I highly recommend going to Mauna Loa. It's a great place, especially this time of year. And you can see it's going up. There's been some blips there. Maybe there was a gas crisis in the 70s or whatever it was, but it's going up. And here's more of a close-up where you can see the diurnal variation, and that's because Mauna Loa is in the northern hemisphere, and during the summer season, lots of vegetation sucks up carbon dioxide, and trees grow, and so it dips down. In the winter, vegetation's mostly dormant, and it goes back up. But you see this trajectory. We're going up, and we're continuing to go up. And here's our first animation, and hopefully there we go. This is global temperatures. You can see the year in the bottom center there, and the blues are colder than normal, and the reds are warmer than normal. And you'll start to see around late 70s, the Earth becomes a much warmer place. These are observations, especially at northern high latitudes like the Yukon. It's a much warmer world. So just a slide showing some of the impacts from a changing climate that are already evident. And there's an arrow here to spruce beetle, which I gather is a problem. I'm not an insect person, but I am aware of the mountain pine beetle. But there's all sorts of things like winter harvesting with roads, aspen dieback due to drought, blowdown. There's all sorts of impacts to a changing climate. Now, we use models, okay? They're called GCMs, Global Climate Models, General Circulation Models, pick your acronym. The best tools we have for forecasting what's going to happen in the future. And you'll recall that I said that 3% of the fires are responsible for 97% of the area burned. And this often is because of a few extreme fire weather days. And so if extremes change, this has an impact on the fire business, on fire activity. And the models suggest that there will be more extremes, whether it's heat waves, droughts, floods, windstorms, ice storms. And if you listen to the news, we do seem to be hearing all about, floods that are 1 in 1,000-year floods that are happening with some regularity. These models suggest warming of up to 6 degrees globally, but that may mean regional areas will be much more, including perhaps parts of the Yukon. Greatest increases high latitude over land, though the Arctic Ocean may be seasonally ice-free by the 2050s, maybe even earlier, according to some of the models, because it's disappearing quite rapidly. It was a low ice year again this year. So here's our animation. So the first animation showed what's been observed, and this is from the Canadian model. There's 20-some models that do these things, and they're all somewhat similar, especially for temperature, more variation in precipitation. But this is what may happen in the future. Once again, the blues are cold, and the warmer colors, oranges and reds, are warmer, and the numbers, you can see like 5, 6 degrees Celsius for the warms and reds. First thing you notice is that it's not warming the same everywhere, and some of the oceans are not warming or even cooling. And that's because of ocean currents, so maybe we should all go to Labrador and buy some seaside property there, because it's not going to warm up so much. But yeah, I think it's still too cool for me anyway. But if these models are anywhere close to reality, it's going to be a much warmer world than present day. So this is work done some years ago, 12 years ago, and this was looking at area burned in Canada, relating it to temperature, and then the change in temperature caused by human activities using one of these GCMs. And basically what it says is that fire activity in Canada is increasing due to human-caused climate change. And I was a co-author in this paper, and I still believe this. There are a number of papers out there that suggest what area burn may be like in the future. And for Canada, early work that I did suggests a doubling. Some more recent work by some of my American colleagues for Alaska and the Yukon, BC, and Pacific Northwest suggests increases of 2.5 to 5.5 times current, which seems excessive, but still, they're all suggesting more fire in the future. So in that work, we found that temperature was really important for fire activity. That is, the warmer it gets, the more fire we get. There's 3 reasons for this, and I won't do it on the order it's in the slide. The warmer it is, the longer the fire season. In Alberta, our fire season officially starts March 1st now. It used to be April 1st, and actually they were actioning a fire in February this year. Our fire seasons are longer. There's papers on it, not done by me, but done by some of my colleagues that say our fire seasons are longer. Second, the warmer it is, the more lightning you get. And this is work that was done in the United States. They found for every degree of warming, you can expect a 15% increase in lightning activity. Everything else being equal, if you get more lightning, you get more fire. So more lightning, longer fire season. And the third reason, which is probably the most important, is the warmer it gets, the atmosphere can hold more water vapor, so it gets more efficient at sucking the moisture out of the fuel. Evapotranspiration increases. So fuels will dry unless there's an increase in precipitation. And what we found is for every degree of warming, you need an increase in precipitation about 15% to compensate for the drying effect from warming. Almost none of the models suggest that type of increase in precipitation. So the bottom line is that the fuels will be drier. The drier the fuels, the easier it is for fires to start and spread. So there was a bad fire year in the territories in 2014, in 94 and 95, and in 2004 in the Yukon. So this is just looking at temperature departure for the fire season and how dry it was. And for 2004, the Yukon, it was the warmest on record. I'm not sure if some more recent years has surpassed it. Don't think this include years 2014, 2015, and 2016. And it was second driest. So warm and dry, it's the hot and dry and windy. So there's been a lot of studies done, and the future looks like there's be more area burned, more fire occurrence, longer fire seasons. We're currently working on fire intensity and climate change, and the preliminary results suggest that fire intensity is going to increase. And this is important for fire management because as the intensity increases, it gets more difficult to extinguish those unwanted fires. It's not safe to get too close to a fire. We use something called kilowatts per meter of fire line. And if it's between 2,000 and 4,000, it's not safe for people to be there. So if it's at the head of the fire, then you work the sides of the fire or the back of the fire where it's not as hot. And then if it gets to 10,000 kilowatts per meter, aerial attack becomes ineffective or less effective. And so basically the fire gets to do what it wants. So fire management is a challenging job. It's going to be more challenging in the future, according to this. So, what can we do about this? And so you go back to the three ingredients that you need: fuel, ignition, and weather. We can't do anything about the weather, okay? We can't do anything about lightning. So that leaves us with fuel and human-caused fires. Fire management agencies, by and large, do a really good job in terms of fire prevention, fire education, and in the Yukon, human-caused fires aren't a big problem. It's the lightning-caused fires. But down south, human-caused fires can be a problem. Fort McMurray was a human-caused fire. Slave Lake was a human-caused fire because, human-caused fires start close to town. Most of them are put out right away, but the odd one gets away and with disastrous results. So the other thing we can do is treat fuel. There's a program called Fire Smart, and fire smarting your home and your community is important. And a lot of it's common sense. It's removing fuel or changing the fuel type. Conifers are extremely flammable. Deciduous, much less so. So you remove trees or change the type of trees so that they're less prone to fire. Building codes can change. Don't have flammable material close to your house. These are all kind of things that we can look at. And there's excellent material on the web available for anyone who's interested. And of course, our Canadian Forest Fire Danger Rating System is great. It's 40 years old and needs some updating. The demands on fire management has changed in the last 40 years, and so this will help us, manage fires in the future. I'm not going to talk long on peat, but peat is kind of legacy carbon. It's been building up over thousands of years. Peat is just organic material that's 40 centimeters or more in depth. And we have a lot of it in Canada. Did a study in Indonesia, peat fires there, slightly different situation because they were draining the land for forestry, but peat fires from one particularly bad year, they estimated was equivalent to 20 to 40% of global fossil fuel emissions, just from Indonesian peat fires. The boreal forest has 30 times more peat than Indonesia. And we're sitting on this, and yes, peat fires historically do burn, and I showed a picture earlier of one burning in November, but they can release significant amounts of greenhouse gases during the combustion phase if they burn deep. And when you have more drought, they can burn deep. And that little graph was done by a colleague of mine, Merit Turetsky. And when you have the bad fire years, it seems like there's more peatlands involved. And that's probably because there's a more severe drought. For upland sites where you have organic layer like the boreal shield, it can dry out in a few days. Peat or bogs, fans, wetlands, they need a drought rather than just a few dry days. So here's the cycle of greenhouse gases. You get a fire, greenhouse gases are released. You've got lots of dead vegetation, decomposes, releases greenhouse gases, and then goes through succession. You have baby jack pine, then you got mature jack pine, and then they burn all over again. And that's the cycle of life in the boreal forest. But this could have a potential positive feedback because with peat, so you got fossil fuel emissions, it gets warmer. It gets warmer, you get more fire, you get more fire, you get more greenhouse gases. So with peat, this could be a positive feedback. Excuse me. Now, I'm going to throw a wild card in here. Recent work on the jet stream. Now, the jet stream is that band of fast-moving air. It's about 10,000 meters above the Earth's surface. And it really dictates where the highs and lows go, the low-pressure systems and the high-pressure, where the weather goes. And there is evidence that the jet stream in the northern hemisphere is weakening. The jet stream gets its energy from the temperature difference between the equator and the polar region. And the polar regions are warming up much more rapidly than the equatorial areas. So that temperature difference is lessening, which means you get a weaker jet stream, which is getting lazy. And so it's like an eddy in a river, and it stagnates. And what happens then is where you have the ridges, which is generally in the fire season, warm, dry weather, you get drought and fire. And in the troughs, you get rain and flooding. Well, if that stagnates and just parks there, well, then we have a real problem because fire is driven by extremes. So if you get that ridge just parked over you, like happened in 2014 over the territories, then you get lots of fire. And so this jet stream weakening is a real concern. This is fairly recent research. Now, before I wrap up, I said I'd talk briefly about Fort McMurray, and I am involved on a research team with Fort McMurray. It started May 1st at 1603. It was detected. It is human-caused. The exact nature of the human activity is still under investigation. Could be a quad. We don't know yet. It was hot, dry, and windy. It was El Nino last year, and I imagine you folks had a mild winter. We definitely did in Alberta, and Fort McMurray definitely had a mild, dry winter. So things were already set up conducive to fire because the snow left early, things were really dry. They had record heat. It was 32.7 just before the fire, and just after the fire, it was really hot, record-breaking hot. 90,000 people evacuated, 2,400 structures burned, 590,000 hectare fire. You can see it in the bottom right there. It's the size of Prince Edward Island. Insurable losses, about 3.6 billion. Costless natural disaster in Canadian history. The second costless wildfire in global history. Negative impact on GDP. There's also the human impact too, that you can't just go by the numbers. This is really traumatic. I have not lived through this, but I've talked to people who lived through Slave Lake and now through Fort McMurray. My neighbor 2 doors down in Edmonton works in the oil patch, and he had a house in the oil patch. I was talking to him, and I said, "What neighborhood was your house in?" And he said, "Beacon Hill." I just walked through Beacon Hill, and Beacon Hill's about 85% of the structures were gone. It was like a disaster zone or a hurricane went through it. I said, "Oh." And he said, "Yeah, I lost my house." And he figured that it could have been much worse. And I agree with him. The highway to Fort McMurray was just recently twinned to be 4 lanes. All 4 lanes were leaving town, north and south. And without those 4 lanes, I'm not sure everyone would have got out in time. Or if there was been one accident, it could have closed the highway. One transport trailer, 18-wheeler, wiping out, and it could have been really disastrous. In Canada, our civilian fatalities are almost nil. Black Saturday in Australia, over 170 people died. I think that can happen here. I think our fire management people are good, but we've been fortunate as well. It could have been much worse. Fire is powerful. One of the senior fire management people in Alberta said, this could have been so much worse. And, harrowing escapes, and, it's miraculous that no one died that night. That was Tuesday night when the fire went through town. People are going to be dealing with this for years and years and years. And the stress, it's almost like post-traumatic stress syndrome. Some people can deal with it, and some people have a real hard time. So that's Fort McMurray. And I've got more pictures of Fort McMurray. The top one is a few weeks after the fire, and you can see it's still a hot spot smoldering there. And this is just above waterways, if you know Fort McMurray at all, just up in the hill there. And I could look down the hill, I could see about 20 or 30 of these little hot spots. But it's maybe hard for you to see, but if you look really closely, there's some aspens that are starting to pop up already. At the same time, it's smoldering just a few meters away from it. And then in September, here we are, different spot, but same kind of deal. These are aspen trees, completely burned, and a whole new crop of aspen coming up. So, fires are a fact of life in our forests, and we'll probably see more in the future. We live, work, play in the forest, and we'll probably continue to develop our northern areas, and that's Ring of Fire in Ontario and everywhere else as people spread and develop. Fire and people will intersect, and we will see more Fort McMurrays, unfortunately. Fort McMurray was a medium risk community, and that's because it's surrounded by aspen. If you recall, I said the conifers are flammable, really flammable. Aspen much less so. And this is what happened to a community surrounded by aspen. Communities surrounded by conifers, and I know a number of them in Canada, are at much higher risk than Fort McMurray was. So we have to reduce the risk, minimize the impacts, but we have to learn to live with fire. There's no way we can eliminate the risk. As long as there's a forest, there will be fire. So fire and weather are strongly linked. Changes in forest fires may be the greatest early impact of climate change on forests. I say it's here already. Fire activity will increase in a changing climate, but will be variable in time and space. So, I don't want to paint too bleak of a picture here. Not every year is going to be a bad fire year. And, like in the Yukon, you may only get one really bad fire year in a decade, And in 30 years, you might have 2 bad fire years in a decade. So it doesn't mean it's Armageddon or the end of the world, but there is going to be more fire, and we have to be ready for those occasions when the Fort McMurrays or Slave Lakes. It could be Timmins, it could be Dawson, it could be Whitehorse, it could be anywhere where you have trees around the community, it can burn. And there's a picture of a particularly severe burn in the Northwest Territories, burned in 2014, burned in 2004, reburned in 2014, and it's kind of like a desert. One of my students was up there this summer, and it is starting to grow back in from the edges towards, but the center still looks pretty close to this. So another picture of a fire. This is from the Territories, and I think it's July 14th, and there's an internet cable that runs along the highway to Yellowknife, and it melted. So people in Yellowknife were out internet for a while. So I'm on Twitter. Check me out if you want. Websites, of course. Western Partnership. It is an interesting partnership. It's unique in that we have a fire management agency, a university, and the Canadian Forest Service all working together on common problems. And we're always looking for good students. So if fire is a passion, come talk to me. Okay? Thank you. So we have some time for questions, I hope. So let's roll.
Who's got the best management system around populated areas?
So the question is, who's got the best management system around populated areas? Well, as I said, you know, fire management agencies the Canadian ones are among the best in the world. Now, once you get around communities, it gets interesting because who's in charge, okay? And it depends on that particular province or territory and that particular community. So around communities, it could be the municipalities or the city or town's responsibility for a fire. So if a fire starts in those areas, the municipality is supposed to deal with it. Sometimes it's really coordinated well, and they contact the fire management agencies, which are provincial, territorial, or Parks Canada, and sometimes D&D does some of their own fire management. So it's a really difficult question. Every community has a fire. Most of those are structural firefighters, and this is where it becomes tricky because wildland firefighters are trained for wildland fire. Structural firefighters are trained for structural fires. So when you get fire in the interface, this wildland urban interface where you have forest and structures, neither side is completely well trained. So it leads to all sorts of problems. And also there's jurisdictional issues as to who's in charge. In Fort McMurray, it was the municipality that was in charge until they called in the province. Or if a state emergency is called, then the province takes charge once that's called. But, you know, in Canada, all our fire management agencies are really good. Municipalities, there's a lot of variability, and I don't know them well enough to comment on that. So I know I kind of danced around answering your questions, but that's the best I can do. Yes?
Yeah, I have a question. Do you also deal with sort of policy options for crisis management? Like one thing I'm aware of in Australia, they made some changes in recent years. One of them being that they made the evacuation orders not mandatory anymore. Based on some really substantial research. They say within 3 blocks, if you have a fire like Fort McMurray, it is so deadly that you can't save it. But homes and structures further away, they don't get torched away like in flamethrower. They only have the amber ignition, and the only reason why all those structures burn down because there's nobody there to water sprinkle them down. So anyways, what do you think about those kind of alternatives and that kind of discussion?
So I personally have limited policy experience. The question was, with respect to policy changes with respect to fire management. And we do have something called the Canadian Wildland Fire Strategy, which was developed that does delve into policy issues. It was signed by everyone, but most of the recommendations have not been acted on, or at least not acted on in full. And policies are changing, and the appropriate response that I talked about, where you deal with each fire individually to see if it's a wanted fire or unwanted fire, is a recent policy change. And I have been working with the people in Ontario, but it's really, I am a researcher. Hopefully some of our research informs policymakers so that it can make good policy. But yeah, I'm a researcher. Way at the back.
My question is about the Fire Smart program. I was wondering if you lobbying or thinking to sponsor the Fire Smart system. I see Fire Smart as sort of locking these into a pattern that it doesn't allow activists to
So the question is implications of fire smart on vegetation and kind of the natural role of the forest. And you're right. It will alter things, but it's generally not a large area. Though I do have a colleague, Dennis Quintilio, who says if you want to keep fire out of the community, just remove all the conifers within 2 kilometers of that community. And, you know, that would be fairly effective. It'd be fairly expensive, but Fort McMurray was pretty expensive, and you can build things like golf courses, ball diamonds, soccer fields in kind of a green belt. It doesn't have to be, you know, like you can still have grass, you can still have some trees, you just don't want to wick into town. Fire is opportunistic, it probes, it's looking for a path, and if you provide that path, like in Slave Lake, there was a narrow band of black spruce along the highway in places, you know, 50 meters wide, and they hit with 18 loads of retardant in 48 minutes and could not stop that fire. So if you break that wick, so it may be like building a diversion for a floodplain. Yes, it's going to affect some of the landscape, but that may be the price we will have to pay to keep it in a state so it's less fire prone. Or if a fire reaches it, it's a lower intensity, so fire management agencies can deal effectively with that fire. Yeah, you should not be burning with peat unless you're really, really careful for that very reason. And, you know, fire smart is still, the effectiveness is still being studied, because when you open up the stand, you allow more sunlight to reach the forest floor, more wind, so the fuels may actually be drier. So it's kind of like a two-edged sword, but the idea is that you won't have crown fires, or you should not have crown fires if you've removed enough of the trees, so that even if a fire does go there, it's lower intensity so that crews can put it out. So the question is, could fire influence salmon? Yeah, it was large scale at 1.8 million hectares. I don't know the answer to that, but I have a colleague who's been studying a Lost Creek fire, smaller than, you know, it was about 23,000 hectares, but that's still a large chunk of real estate. I've driven through some 10,000 hectare fires, and it's taken me 45 minutes on a gravel road to get through one end of the fire to the other end. And he's been looking at the impact on water for the last 10 years, and he's a big fisherman, so he might know the answer. But I don't know the answer to that question, but it's conceivable that, you know, it would have a large-scale impact. It does affect water quantity and quality, because runoff changes, and there's all sorts of material that can be carried into the water, which could impact fish. I think I'll go with this gentleman first, and then I'll get you, and then there's some over here. And okay. So the question is the insurance industry waking up to a fire problem, a forest fire problem? The answer is yes. they've been talking about for the last couple, 3 years. There's something called the Institute for Catastrophic Loss Reduction, and it's funded by the insurance companies. And they had people in Fort McMurray taking measurements about which homes burnt and which ones didn't, and that's going to be presented at a conference next week, actually. So they are getting interest. They haven't actually changed policy pricing yet in Canada. I believe State Farm in the States has, at least in some regions. Now, there you get a reduction if you're a fire-wise community or fire-wise area, which is like our Fire Smart program. So yes, because, and with losses like we've just seen recently with 2,400 structures lost, this is a significant impact. So before I go here, there were questions way at the back there, and then we'll come forward. Okay. Ouch, 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 ouch. Yes. But I will say that, there was Beacon Hill, okay? And there was some in Slave Lake too. Beacon Hill, it was just a narrow, it was just a very thin strip of fire smarting, and the fire just jumped over it. But there were areas in Fort McMurray where there was a cemetery, and they had green grass, and you could see that there was much less destruction downwind from that cemetery as opposed to the areas. If fire smart treatment had been done, more completely, I think there would have been a difference. But where it was done, it was maybe 10 meters, and yeah. So yes, there were fire smart. So there was someone farther back, and then I'll come forward. Any questions back there? Okay. So, yep. Well, I didn't talk about it, but actually there are some communities that have adopted somewhat that approach. Prince Albert has a strip essentially like that. So it is an option. It may be cost. I also didn't talk about sprinklers, which I think on occasion are quite a viable solution, or in tandem with Fire Smart. So I'm sorry, I'm supposed to repeat the question every time, and I've been 50-50 here. So the question was, why not just remove all the fuel around communities? And yeah, that is an option, and a couple places have done it or looked at it. So before I go here, there was a gentleman here.
Do you have any comments or observations about the White Horse? Because when I hear you describe Fort McMurray and 7th Street, it sounds to me like we're just good to go here.
Well, it's snowing right now, and I was here 20 years ago, and there's conifers around. So yeah, I'm not sure if there's any fire smart treatments in White Horse. I hope so, but there are a lot of conifers, so be vigilant, definitely. Good. Over here, question? Okay, so the question is, what's the effective fire smart treatment and fire guard, and the cost benefit of that guard. I'm not an economist, so I'm just going to say I can't do the cost benefit side of what's the expenditures. So the problem becomes fires generate this rain of burning embers. And if you saw some of the video from Fort McMurray, you saw them while they were driving out it's raining embers, okay? And Australia has a real problem, but we still have a problem too, in that these burning embers can be carried by the wind some distance. In Slave Lake, the fire was 2 kilometers from town, and a spot fire had started in town. In Australia, they talk tens of kilometers, but for the Boreal, about 2 kilometers is maximum. So if you really want to do a fire guard properly, that's why my colleague says remove all the conifers from 2 kilometers around the community and you got your problem solved. It's because this burning rain of embers is what burns most of the houses down except for those first few blocks adjacent to the forest, which are, if it's a raging crown fire, those first 2, 3, perhaps 4 blocks they're gone, okay? And you just get out of the way. Oh, but everything else beyond that, it's the embers falling down, hitting the needles on your roof, hitting your deck, hitting something that can catch. It's just looking for a spot. It only takes one. And you know, we did some numbers in Slave Lake, and we're calculating for Fort McMurray about how many burning embers per square meter, and it's significant for a fire like, you know, Slave Lake and Fort McMurray. So it's testing the waters, and it's looking for a spot to burn. So that becomes a problem for a fire guard. How wide do you make it? Because 2 kilometers really isn't practical, okay, for a fire guard. For greening the landscape with golf courses and ball diamonds and soccer fields and thinning some of the fields, well, for bigger communities, maybe that's reasonable. For a smaller community, cost benefit, but then you're protecting human life. And, you know, I guess the people in the business do put value on human life, but I can't, so. Yes? So it was more of a comment than a question, and it was about fire smart. You have to look at the different scales from the homeowners to the community, and that is correct. What I will add, though, is that you can be a homeowner and do everything right, and you have 2 neighbors on either side who do everything wrong. You're in a bad spot. So this is why a fire smart community is much more effective than just doing your own home. Yes, do your home, but have the whole community involved so that you don't go down with your neighbors. If the area's been fire smarted appropriately, it'll be a much lower intensity fire, which is easy for fire management crews to put out. That's the intent, that's the purpose of the fire smart treatment. So if it's done right, it does work.
We also have to remember that you talked about the two choices of fire. Another thing the fire smart does is typically around the public area. If you take away the ground fields, which is where people play with fire, usually it's growing up. And so maybe that helps a lot.
Yes, I won't tell you a story about matches and a 7-year-old boy in Grantham, Alberta. But anyway. Okay, so the question is about, with the recent devastating fires, is there more discussion on prescribed burning as an effective tool? And, you know, the fire smarting can be done mechanically or through prescribed fires. And I was actually in the United States recently, and I was having this discussion, and they were told point blank, people don't like smoke, and they were not, this is California, it's almost impossible to do prescribed fire in their community now because of smoke. That people just say, I can't see the mountains, it's bad for my health, we don't want smoke. So it's really difficult. But yes, it's effective if we can do it. Do you have a follow-up? So the question is, would education help? And yes, education would help. And I often tell people that, you know, hey, I don't want a little smoke. I said, well, pay me now or pay me later. But if you pay me later, you're going to get a lot more smoke than you bargained for. So a little smoke now versus big smoke later. So, but yeah, we have to educate. Yes, and then I'll come over here. It's designed to burn, yes. Okay, so the question is using prescribed fire every 5 years, and so there's kind of a maintenance aspect, which is still some ongoing research with Fire Smart. I don't want to misrepresent. There are some surface fires in the boreal forest. The big ones are often crown fires. But at night, it does cool down, and there are wetlands where it'd be a surface fire. But there's also parts of the mountains where you have montane, where you can get a mixed fire, the parts of Alberta where this applies. And that's a different regime than the typical boreal, which is appropriate for most of the boreal, but there are areas that have, can have frequent surface fires. BC, some of the ponderosa pine, for example. That's all fair game. So, there is some variety and there is some surface fires, but Fire Smart treatments need to be maintained. Maintenance is a big issue, and it depends on the vegetation. Some may need to be treated every 2 to 3 years, some every 10. It depends on the circumstances. Yes? Wire vapor, yeah, of the natural greenhouse effect, yes. That's a good question. Liquid wires. So the question is, wire vapor is a greenhouse gas, and is it going to increase in the future? And I don't know. It's possible, especially as you mentioned with the Arctic Ocean becoming seasonally ice-free, that there's much more evaporation going on when there's open water as opposed to ice. So perhaps. Yes, it's more effective at evaporating. Yes. Yeah, it's part of the whole climate system, which has lots of checks and balances. There was a comment or question here, and then I'll come back. Okay.
Getting back to the research, what are some of the big interesting research questions?
Well, there's kind of two things that I'll mention. So the question was, what big research topics or questions are out there right now? In terms of fire, well, I mentioned for the climate change stuff, the fire intensity, fire behavior in climate change. No one's really, there's been little pieces done, but no one's done it comprehensive, and we're getting results, you know, as I speak. I have someone who's working today. I don't know why she's working, but anyway, she's producing maps for me for this conference in Kelowna next week, Wildland Fire Canada conference, and I'll be presenting some work with colleagues about fire intensity and climate change. So I see that as one. The other is a little more complicated, and you know, I presented a case for a positive feedback with fire and climate change. That is more fire, more greenhouse gases. But there is some argument by some Americans and published work that suggests if you get more fire, especially in the north, it will cause a cooling because of albedo. Their argument there is if you have a fire, then when you have snow, albedo reflects the energy back into space, and snow is a really good reflector. So as opposed to having conifer trees, which stay more or less green during the winter and absorb solar radiation. But conifers come back as conifers. It's more of a deciduous thing. I still haven't bought it, but that's a research area to say, are fires causing climate warming or climate cooling? And yeah, we're working on it.
One of the effects you were saying, you're likely to get more intense fires. Are we going to see a change in the type of forest? Are we going, I mean, we've seen the carbon cycle on that. The nitrogen cycle is affected by this because I think I've read somewhere that like 95% of the nitrogen in the woodlands next to the Yukon River was fixed by the alders at that stage of the cycle. We're changing the cycle, we're changing the distribution of, are we going to get invasion of aspens replacing the jack pine? What's the story?
Okay, so the question is, if the fire regime or the amount of fire and the type of fire behavior changes, will the forest change? And if it becomes frequent enough or intense and frequent enough, yes, things will change. And this is another debate and maybe perhaps another question that needs to be answered. I have colleagues who argue forcefully that as we see more fire, we're going to see more aspen, okay? And then I have other modelers who say, no, 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 no. You get more drought and more fire, and you're going to see more conifers because the aspen cannot handle the drought. In all their models, the drought's killing the aspen, and the conifers survive. But if you get too much fire, then you're not going to have any trees. You're going to have shrubs and grasses and things like that. So, but the bottom line is whether it's conifers or aspen or shrubs or grass, as long as there's vegetation and ignition and the weather, we're going to have fire, okay? So the intensity may change, the type of fire may change, but fire is the common denominator in all these vegetation types. So we're going to see fire. And they're cutting me off. So here, then here.
The city of Whitehorse has a harvesting policy where they have designated sites to harvest, but it only states that you can harvest trees that are down or dead and down. I think the city of Whitehorse changed its policy to allow people to harvest green trees that most likely will have the event of fire.
Yeah. So the question is, can harvesting take place close to Whitehorse to help prevent fire? And you know, this is a good strategy, but it should be married with a fire smart strategy so that you know you can do the fire smarting and harvesting in some appropriate sharing fashion, if at all possible. But yeah, I think you know prescribed fire, logging around communities in a coordinated planning way should be looked into and possibly encouraged if it's a good fit. And maybe this is the last question. Okay, last question.
Well, for years and years,
So the way we manage our forests, has this resulted in a change in fire? If I can rephrase the question. And the Americans have been arguing about this, saying that, hey, we've been so successful with fire suppression that it's changed the nature of the forest. And so that when a fire does happen, it's much more severe, intense, and harder to put out. And in certain forest types, I think that may be correct. And ponderosa pine is one example where I believe it's correct. For around here, I'm not sure if our fires, the boreal forest is so vast, and fire, as I said, kind of looks for pathways. So if you got a lake, it goes around the lake. So if we suppress fires that would have grown, the next one usually gets it. I mean, don't get me wrong, I think fire management has reduced area burned in places. I think it has an impact, but is it a big enough impact to affect subsequent fires? I'm not sure, because the fuels, there's generally enough fuels, you know, once it's given time to recover from a fire to reburn, generally, okay? It depends on this, you know, if it's a bog, you know, yeah, then it takes longer before it can burn again, sometimes 60 years before a bog will reburn, whereas a fen can reburn the next year, okay? But totally different systems. So maybe I'll stop there.
Yeah, thanks very much.